In this class, we'll define my linked list. We'll call it my linked list because linked list by itself corresponds to a collection that belongs to Java. As a matter of fact, if you import java.util.linked list, you can use the library linked list from Java. We'll talk about that later when we discuss collections. For now, please avoid incorporating these libraries. That is primarily the main reason why I call it my linked list, because we're defining our own linked list, not the one used from Java. Linked list has only two fields, first and last. Both of them are nodes. First corresponds to the very first element in the linked list, and last will be the last element in the linked list. Let us create our constructor of linked list. The default constructor corresponds that the first and last will point to null. It doesn't hurt to have a method called isEmpty. IsEmpty returns true if the first one, which means the very first element of the linked list, points to null. That only means one thing: there's none elements in the linked list. That will be more than enough to return true or false. The next method is add. Add will take an element, a string, because we're holding strings in our class node. If you remember, our data, its data type is a string. So therefore, when we add an element, it has to be a string s. Since the linked list holds nodes, we must create a temporary node using the second constructor from our class node, the one that takes only one string. We're going to incorporate the value s into the node. Therefore, we're going to add it always to the end. Every time you add an element, we need to check two cases. In case the list is empty, then that's the easy case. That only means the first and last is the same as the element n that we plan to add. Otherwise, we're going to add it to the end. Now, we need to be careful. How are we going to add to the end? I want you to pay attention in the following thing. We usually add at the very end of the list. Therefore, last will play an enormous role here. But it's not as simple as adding last to that value. If we do this, that corresponds that the last element will point to the value n that we just generated. And that's not what we want. We first need to link the .next. Remember that last .next is null, but no longer will be null because we're going to point to the element n that we just declared on line 12. Once we establish this connection, then we add the element .next from the last element to the value n. When we're done, we only need to redirect the reference of last, which is last. Now we'll point to last.next. This is very important. Make sure you first establish the link to the last element, to the value n. And after you make that connection, then you can point to the last, to that value. Now we have two cases. In case it's empty, that is the simplest thing. First and last will point to the value that we're trying to generate on line 12. But in case it's not empty, then we're going to go to the very last element, connect to the .next to that value, establish the connection, and the next step is only pointing or referencing the last to that value that we just add. Let's test this class by creating a tester. First of all, let's create my linked list instance. I'm going to call it list, which is an instance of my linked list. The next thing is to test isEmpty. isEmpty will basically be here true because list there's nothing there. And we can safely call isEmpty from the instance we declare on line 3. Now let's add a couple of items into our list. If we call our method isEmpty after adding the elements, now we expect false. I'll put the system out print line just to provide information about adding the elements. Let's save, compile, and run this program. We can see that right here isEmpty is true at the very beginning. After adding the elements, when we invoke the method isEmpty, it will turn false. because now you have elements in the list.